Good morning, students. So we have come to the last unit in mathematical physics. So this is about differential equation, and we discussed earlier about mathematics. Physics has been written in terms of mathematical language. So all physics steps is involved in mathematical steps. So mathematical language. So mathematics and physics should go hand in hand. Only then we can understand the concept of physics. And of course we can have lot of steps through mathematics. The result should be interpreted in terms of physics. That's why I said mathematics and physics should go hand in hand right from the beginning. So when Newton's laws were discussed, it was introduced by Isaac Newton, and all mathematical steps were involved, especially differential equations. Suppose if I know initial conditions for any differential equation, suppose we are going to throw a stone from one place to another place, and if I know the initial condition, if I know the initial velocity, I can find out where the stone will be after 5 minutes. I can find out the whereabouts, the height, the velocity, the last point, and all those things we can get from easy mathematical steps. So differential equations are very, very important. So after 200 years, there came Maxwell. Maxwell also introduced differential equation, and in fact he introduced first order differential equation, simple order, first order differential equation. Maxwell's equation, probably which we have already read in electromagnetic theory. So in which we have first order differential equation, and we are going to talk about quantum mechanics later. In quantum mechanics also we have differential equations. So in fact Schrodinger equation involves both single order and double order differential equations. So differential equations are very, very, very important. So almost in all the theories they involve differential equations. So we'll have to differentiate something, differentiate a function, we'll have to differentiate a variable, we will get some solution. For example, when you take Schrodinger wave equation, the solution of Schrodinger equation will give you the solution of quantum particle. So quantum particle in terms of position and time can be derived from Schrodinger wave equation. Not only in Schrodinger wave equation, but also in relativistic quantum mechanics also it is used. So differential equations are very, very important. So in almost in quantum mechanics we always use differential equations. So provided we should know fundamental concepts of differentiation and integration, we should know. So only then we can solve some tedious problems. So in this unit, mainly we are going to concentrate on second order differential equation, and of course first order differential equation also should be needed. So we are going to discuss the second order differential equation and Sturm-Liouville theory, and here also we have Sturm-Liouville type equation. So put together we are going to discuss. Then series solution with some examples. Power series, we are going to use power series, Hermite polynomial, then generating function of Hermite polynomial, orthogonality properties, recurrent relation, and all those things they come under Hermite differential equations. Then next comes Legendre polynomial. So Legendre differential equations, the solution of Legendre differential equation is nothing but Legendre polynomial. And also we are going to discuss generating function, Rodrigues formula, orthogonality properties, Dirac delta function, all those things they will come under Legendre differential equations. Then Green's function. So Green's function most probably will be using in scattering theory, in quantum mechanics 2. So Green's function and the reciprocity theorem, Sturm-Liouville type of equation in one dimension, and their Green function. So we are going to learn mainly two differential equations. One is Hermite differential equation, another one is Legendre differential equations. In fact, they are used to find out the solution of differential equations, which are nothing but quantum particles. And of course, other two are there, which are not in your syllabus, Bessel and Laguerre. So there are four differential equations, which are not there in your syllabus. Four. One is Bessel differential equation, Bessel function. Another one is Hermite, Legendre, and Laguerre. So four are involved. So they all come under differential equations. Okay, with this introduction, we'll start differential equations. In general, the differential equation goes with this type of equation. So differential equation will go with this type of equation. So we have d squared y by dx squared plus p times dy by dx plus q times y equals 0. So this is the type of differential equation. Okay, first point. Second one is, what about your y? Y is a function of x. Correct? D squared y by dx squared, it clearly says that y is a function of x. X is an independent variable. Y depends on x. So y is a dependent variable. Is it okay? Y is an independent variable. Y depends on x. As I said just now, y is a function of x. So y depends on x. X is an independent variable. Y is y dependent variable. Y is. What is the order of equation? Order of equation, because 2 times you have differentiated, the highest order. So that's why order of your equation is 2. P and Q are some constants. So they satisfy this is equal to 0. Okay, so right hand side answer is 0. If answer is 0, then we say that it's a homogeneous equation. Suppose if it is not equal to 0, some polynomial, some trigonometry, some exponential function exists, then we call this as inhomogeneous equation or non-homogeneous equation. Okay, so here it is right hand side is 0, so it's a homogeneous equation. Then the general solution of this equation is nothing but complementary function plus particular integrals. So this is complementary function plus particular integral. Suppose if it is equal to 0, then there will be no particular integral. We are going to find out only complementary function alone. Suppose if it is not equal to 0, for a inhomogeneous equation, it cannot be equal to 0. Then we will have to add particular integral. Is it okay? First slide. I repeat, if it is equal to 0, there will be no particular integral. If it is not equal to 0, we will have to include particular integral term also. So this is the complete solution, general solution. Now, complementary function. So we are going to discuss now complementary function. The characteristic equation, any equation can be written as, say for example, x squared plus px plus q equals 0, for example, or otherwise you can write r squared plus pr plus q equals 0. So this is a auxiliary equation, or sometimes we call this as characteristic equation. Here r1, this is quadratic equation, correct? This is quadratic equation, so that must be 2 roots, 2 solutions. So r1, r2 are 2 roots. Suppose if 2 roots exist, if they are not equal, 2 roots are there, one root is 2, another root is 3, one root is minus 2, another root is plus 3, for example, then r1 is not equal to r2. In that case, the solution of this equation is y equals c1 times e to the power r1x plus c2 times e to the power r2x. So this is the solution. You will have to learn by that. You should know. Suppose if the roots are equal, then y equals c1 times e to the power rx, because roots are equal, r1 equals r2, which is equal to r. Then c1 times e to the power rx plus c2 times x, this is x, e to the power rx. You pull e to the power rx common out, you can write this as c1 plus c2 times x into e to the power rx. Suppose if the roots are imaginary, okay, for example, r squared plus 4 equals 0, okay, possibility is there. So if roots are imaginary, then r equals alpha plus I beta. In that case, the solution will be y equals e to the power alpha x, real number, multiplied by c1 times cos beta, imaginary number, beta x plus c2 sin beta x. So there are 3 methods, 3 types. We will try to solve, we will understand. First we will go with this problem. Okay, so differential equation, we are going to solve this one. So d squared y by dx squared minus 7 dy by dx plus 12y equals 0. So the characteristic equation is given as r squared minus 7r plus 12, which is equal to 0. See, you just pull y out. You just pull y out in that equation. So you have d squared by dx squared. You write it as r, that's all, r squared. You pull y out. So r squared minus 7r plus 12 equals 0. We can factorize into r minus 3, r minus 4. Okay. So we have r minus 3, r minus 4 equals 0. What are the roots? R1 equals 3 and R2 equals 4. They are not equal. So we will have to use only the first one, which is equal to y equals c1 times e to the power r1x plus c2 times e to the power r2x. So the first root is 3x, the second one is 4x. So this is a general solution. As we discussed here already, that PA equals 0 because this is equal to 0. Homogeneous equation. Is it okay? Because this is equal to 0. So there will be no PI's. Particular integral, there will be no PI's. Is it okay? We will go for second problem. So we are going to solve this problem. D squared y by dx squared minus 8 dy by dx plus 16y equals 0. The characteristic equation is given by this equation, r squared minus 8r plus 16 equals 0. You factorize this one, you will get r minus 4 into r minus 4. Look over here, roots are equal now. See, r1 equals r2 equals 4. So we will have to use only the second one, which is nothing but c1 e times 4x plus c2 x e to the power 4x. See here, you can pull e to the power 4x as common out. You can have these two, c1 plus c2 x into e to the power 4x. So this is the example of second one. So now we will go for the third one. We are going to solve this equation, d squared y by dx squared minus 6 dy by dx plus 25y equals 0. As usual, the characteristic equation is given by this, r squared minus 6r plus 25 equals 0. We can't factorize this one, it's difficult to factorize. We will have to use this formula, minus b plus or minus root of b squared minus 4ac divided by 2. So as we have done this, and you can simplify, this becomes 6 plus or minus root of minus 64, and this can be written as 6 plus or minus 8i by 2. So 3 plus or minus 4i. So we will have to, this is of the third type. So your answer will be y equals e power alpha x. What is alpha x? 3. So c1 cos, what is beta? 4x plus c2 sin 4x. So that's the answer. Any doubt? Okay. Now very important one more question. You should know what is an order, what is a degree in a differential equation. You should know what is an order and what is a degree. Degree means power. Order means the highest derivative. For example, the highest derivative is single differentiation. See here, just we have differentiated with respect to x, single, only once. That's called order. What is the power? Power is nothing but to the power 1. dy by dx to the power 1. That's called degree. So degree is 1 here, and the highest derivative is again 1. You go for here, see to the power 2. So your degree will be, power will be 2. What is the highest one? Only once only we have differentiated. So your order will be 1. Very important one more question. It's easy to remember. And what is this one? 2 times we have differentiated. So the highest derivative will be 2. What is to the power 1? This is to the power 1. So degree is 1. Simple. Is it okay? So you should know for any differential equation, at least you should know what is a degree and what is an order. How many times you are going to differentiate with respect to x, that you should know. What is the power? That's very important to differentiate whether this equation is linear or non-linear, which we are going to discuss now. This order only determines whether this equation is linear or non-linear. Okay, we are going to discuss. So this is about linear and non-linear. For any linear equation, for example, we take in quantum mechanics, Schrodinger equation is a linear equation. Whereas Newton's laws of motion, those equations are non-linear equations. Okay, so here linear equation means there are two conditions should be satisfied. One is it should have only first order should be 1, the first point. Second one, there should be no product. For example, when you take x and y, okay, x and y should not be go together. That means it's non-linear. I repeat, there are two conditions should be satisfied. One condition is order should be 1. Single order, it should be 1. Second one, x and y, they should be always separated together. Okay, two functions should not go together. They should not go together. Okay, and also when you are going to have with trigonometry function, this is trigonometry function. When you find trigonometry function in differential equation, surely it will be non-linear equation. Another idea. Is it okay? When you are going to find out the trigonometry function, sine, cos, tan, so they are all trigonometry function. Suppose if any differential equations involve trigonometry function, then we can say that this will be a non-linear differential equation. Simple idea. So we'll go for first one. You have to find out whether it is a linear or non-linear. We can check. Very important one more question. Often this question may appear in the examinations. See, y prime means dy by dx. Y prime plus x squared equal to 4. Whether it is a linear or non-linear? Linear equation. See, look over here. Y prime. Okay, dy by dx to the power 1. There is no x and y separate. X squared it can be that, doesn't matter. This is okay, but this is very important, dy by dx, that is very important. We'll have to only go with a dependent variable, not independent one. So this is a linear equation. What is the second one? Why it is non-linear? Very good. 3y squared, see y prime squared, dy by dx whole squared is there. So it's a non-linear equation, very good. Third one. Why it is non-linear equation? Here it is on the other way around. It usually will go for d squared y by dx squared. Can you remember? But this type, so tricky is that d squared x by dy squared. Y is an independent or a dependent variable? Why? Y is an independent variable. According to this, you have to say y is an independent variable. X depends on y. Okay, y is independent variable. X dependent on variable, so x is dependent variable, which depends on y. Here x squared is there, so it's a non-linear equation. This one, immediately you can say sine term exists. Here also sine term exists, and also it's a product. See here, product y is sine x. I told you, so there should be no product. See here, products of derivatives, no product. So this is non-linear equation. Is it okay? So dy by dx, y is independent variable and x is independent variable. Oh, here I have made a mistake. Y depends on, so y is an dependent variable. Y depends on x. So that's a mistake here. Okay. In physics, that is in terms of mathematics. Whereas in physics, usually we'll go with definition of linear operator like this. Suppose you have two operators. See here, you have an operator, two functions are there. Operator operate on the combined system. Operator operates on the combined system is equal to operator on the individual system. That's called a linear one. In physics, usually we'll think of only definition for linear is exactly like this. I repeat, operator operates on the combined system will give you operator operates on the individual system. See here, a1 y1 plus a2 y2 is a combined system. Here the answer is, see, y1 alone, y2 is alone here. See, it's individual system. Operator operates on the individual system. If the differential equation obeys this rule, then we say that this is linear operator, linear differential equation. In physics, usually we'll term like that only. For example, you just take this differential equation. Okay, so linear operators are, this is your linear operator. See here, this is your operator. This is your operator. So that's why linear operator is given by this. Now I am going to add these two, a1 y1 plus a2 y2, and substitute here. So when you are going to substitute, you can write this one individually. Correct? You can write this one individually. D squared by dx squared a1 y1. You pull a1 out. So a1 d squared y1 by dx squared. Correct? Then plus a2 d squared y2 by dx squared. Similarly, you can write this one as px d a1 y1 by dx plus px d a2 y2 by dx. You can write separately. Similarly, the last term also we can write separately. a1 y1 terms and all you can write it separate first term. Then a2 y2 and all you can write in the second term. When you are going to write this as, you can write this as individually. So this is called the linear operators. So linear operator means operator operates on the combined system will give you operator on the individual system, separate system. We will try to solve the differential equation using separation of variable. So now we are going to go with first order differential equation. So this is first order differential equation. We will have to understand, it lies in the syllabus. We will have to understand what is first order differential equation using the technique called separation of variables. Separation of variables, it's suppose if any equation or any differential equation contains 2 or 3 parameters. For example, r theta phi. 3 parameters are there, correct? 3 coordinates are there, r theta phi. Then we can separate into r terms, we can separate into theta terms, we can separate into phi terms. These techniques are called separation of variable. Suppose there exist two variables, y and x. For example, y and x. I am going to separate y alone one side, x alone on the other side. Suppose if I can have x, y, z, 3 variables, x, y, z, t, 4 variables. I can separate into all the terms, what we call technique as separation of variables. So now here it involves only y and x. There are only 2 variables, and also we are going to have only first order differential equation. So you have dy by dx plus solve, okay, plus 1 minus y squared by 1 minus x squared to the power 1 by 2, which is equal to 0. Now given that I have written the same thing, and I have brought this term to right hand side. See, this term I have taken to right hand side. To the power 1 by 2, I have written separately. Now dy by dx equal to this one. I can bring this term to this side. I can bring this term to that side. I can bring dy, let it be like this. I can bring this term because it involves only y. So bring this term alone to left hand side. That will give me root of 1 minus y squared here as a denominator in the left hand side. I can take dx to that side, right hand side. Finished. That is the answer. Simple. So I have done the same thing. Dy divided by root of 1 minus y squared, which is equal to minus dx divided by root of 1 minus x squared. I can bring this term to left hand side, which is equal to 0. Now you are going to integrate on both sides. So when you are going to integrate on both sides, you will get the answer. So integration of this is equal to this. Differentiation of this equal to this. It's easy to remember. Differentiation of sine inverse y equals root 1 divided by root of 1 minus y squared. When you are going to integrate, you will get the answer as this. When you are going to differentiate, you must get this answer. So easy to remember is just to differentiate sine inverse of y, you will get the answer as 1 divided by root of 1 minus y squared dy. So which is equal to some constant, integration constant c. Simple idea. Now second problem. Again, this is first order differential equation, correct? First order differential equation, and we are going to use a separation of variables. So tan y secant squared x dx plus tan x secant squared y dy equals 0. So it is given. You just bring this term, just take this term to right hand side. Okay, right hand side. Now I am going to keep secant squared x as it is. I am going to bring this tan x here. So you will get secant squared x divided by tan x dx, which is equal to secant squared y divided by tan y dy. See, look over here, we have separated now. This is in terms of x, this is in terms of y. So bring again this term to this side and integrate on both sides. When you are going to integrate on both sides, you will get this. Okay. So I have done the same thing. So after the integration, the answer is log tan x. The answer of integration of this will be log tan x. What's the differentiation of log tan x? Log tan x 1 by tan x. You are going to differentiate tan x, that will give you secant squared x dx. See? Is it okay? Simple. You are going to differentiate this. You must get this answer. Log tan x equal to 1 divided by tan x. You are going to differentiate tan x. Answer will be secant squared y. Similarly, you will get the answer as log tan y, and which is equal to the integration will be c. Usually c, but here log is there, log is there. That's why I have written as log. Okay, now log A plus B, log B formula, log AB, so log AB. Okay, log AB equals log A plus log B, correct, which is equal to log C. Now log will cancel, the answer is tan x tan y equals C, that's all, simple. Now we'll go for some other problem. Xy square plus x dx plus yx square plus y dy equals 0. So equation is given us like this. First you have this term here, you bring this term to this side. Okay, first point. Then second one, you pull y out here, you pull x out here. Then you keep y here, you bring y square plus 1 to the left hand side, you bring x square plus 1 to the right hand side. You just take this term to right hand side. Then I can multiply on both sides by 2. Because when you are going to differentiate, you will get 2y. That's the reason only y exists. Okay, so I am going to multiply on both sides by 2 and integrate. So what is the answer? When you are going to integrate, the answer will be ln y square plus 1. When you are going to differentiate, answer will be 1 divided by y square plus 1 2y dy. You will get the answer. Similarly, you are going to integrate, you will get the answer. Again plus ln c. Okay, so that's the answer. So after that, what you have to do? You have to simplify. You just take this term to left hand side, use log rules, log a plus log b, log ab, which is equal to log c, and log will cancel, you will get the answer. So this is the required solution. Any doubt? Simple one.